rounding out. Section 4.7 is just a little bit of order of operations with fractions. This is not anything too wild. It's essentially just that, at this point we've kind of seen almost all the arithmetic we could hope to see with fractions. I think we've been pretty thorough. And so the idea here is just let's make sure if we kind of just we're given a sort of pile of Mad Libs style, just like pile of fractions and operations, that we could just sort of work our way through it. Quickly, right? Order of operations. Usually, what everybody remembers is PEMDAS, right? P is any parentheses or any kind of grouping tool, right? So that could also include brackets, or in some sense even something like like an absolute value would count. E is for exponents and any type of roots. So exponents and roots, right? They're sort of two sides of the same coin, so they kind of have the same priority level in any kind of order of operations situation. Next, and so here's the only part of PEMDAS I don't love. It's really multiplication and division side by side. So you're going to do multiplication, division, just in order from left to right. So the one thing I don't love here is PEMDAS always makes people think that you have to do all of your multiplication before you do your division. But technically that's not how it goes. The idea is that multiplication and division are really sort of, again, the same kind of priority. They're sort of two sides of the same coin. So if you don't have any other grouping kind of things that are sort of telling you to do, one before the other, parentheses around your later terms or something, you're just going to run it in order, just like you were sort of reading a sentence in English from left to right. Right, the words from left to right, you're going to do the exact same thing with your operations. And then addition, subtraction, again, just in order from left to right. So you're not necessarily going to do all of the addition before you do the subtraction, even though if you remember PEMDAS, that's probably what you're going to think. So this is sort of a blessing and a curse. It's a pretty memorable thing. A lot of students will remember PEMDAS. The downside is if all you remember is PEMDAS and you don't necessarily remember the details of what's happening, it can get you in trouble in a couple specific cases. So what are these things going to look like? Nothing too wild. Obviously, you can put 15, 20 numbers into one of these things. The point is not to make a big pile of numbers, just to make sure in certain scenarios we can work our way through it. So let's say we have sort of 1 over 4 squared. We're going to divide by the quantity 3/8 plus 1/4. So let's sort of run through this. We, in some sense, have kind of two things we could do first, I suppose. Something like 4 squared. It's, even though exponents are not necessarily the first thing in our list, 4 squared is obviously sort of just by itself on the bottom of this fraction. So it's totally reasonable to do that square, right? Do 4 times 4 and just sort of get a value there. The next thing, sort of obviously, P for parentheses. So all the stuff in the parentheses here is going to be sort of the sort of other first step that we're taking. So to deal with that, it's its own little problem. We have to sort of find common denominator for us, our LCD here. 8 and 4, we can just use 8, right? We can just sort of do, right, 4 times 2 and 1 times 2. So this is going to become for us, right, 3/8 plus 2/8. Done and done. So that's 1/16. Divide by, right, we can just add these guys up. So then that would be 5/8. So we do that addition first, get that combined to one fraction, then we're just left with a quick division, right? So then this is going to be 1 over 16 times 8 over 5. And from there, we're just doing a quick, right, cancel some common stuff out. 16, 2 times 8, we can go 8 cancels 8. This is going to leave me 1 over 2 times 5 is going to leave me 1 over 10. So, not unreasonable, right? Not gigantic. In theory, of course, you could make these sort of as big as you wanted to, just sort of stacking and combining numbers on numbers on numbers. That's not exactly the point of this, but you could do that. We're going to try to keep these a little bit more manageable we've only got so much time in these videos. Let's maybe just do kind of one more. How about something like 7/8 minus 3/4? Let's square it. Let's add it to the root of let's do the root of 9/4. So this is a couple things going on. There's exponents here, there's roots. We sort of briefly did exponents and roots right back in 4.3. I probably almost made it sound like we're never going to use it, but hey, here it is again. So I didn't mean to sound like we were never going to use it. 2 places to start. We have a pretty similar inner parentheses here, kind of similar, maybe a little too similar to the one we just did. 8 and 4 again, so we know our LCD here has got to be 8. So we'll do times 2 and times 2. We need to do that before we square this, right? Everything is in my parentheses first, so that means I have to clean up all of my values in there, try to sort of combine them down. This would become for us, right, 7/8 minus 6/8. Excuse me. Whole thing gets squared. This is going to be added to the root of 9/4. Anytime with an order of operations thing, if you have sort of addition and subtracting separating yourself into different chunks, you can kind of simplify each of those chunks at the same time and then just sort of add and subtract them as a last step. So you don't need to sort of only work in the parentheses at first, right? You certainly can do that if you don't want to do too much. I'm going to get a little greedy, and I'm going to say we can sort of also start to simplify and apply this root. So what we said before is if we have a square root of a fraction, what you do is you take the root of both the top and the bottom, right? You sort of distribute that root over both of those terms. So what's this going to leave us with? Well, 2 things, right? 7/8 minus 6/8, that's going to leave us 1/8. That whole thing is going to be squared. Plus, so root of 9 over root of 4, that's going to be 3/2. Right? Root of 9 is 3, root of 4 is 2. 1/8 squared, so that's going to be 1 squared over 8 squared. Plus 3/2. So these fractions kind of heading in the opposite directions. What we're going to get here is a 1 over 64. Right, we're getting a bigger and a bigger and a bigger denominator here when we sort of apply this root. And then the other one, because we were doing, apply this power. When we applied the root, we actually got smaller values. Now, once all that is sort of said and done and cleaned up, we're left with a quick addition. We got to do 64 and 2. The common denominator here, right, 2 we can sort of multiply by 32 on both of these to get a 64 on the bottom. These guys are pretty far apart, but it is what it is, right? We never said we were only going to work with 3s and 4s and 5s. 3 times 32, what are we going to get? 96 over 64. So then, 1 over 64 plus 96 over 64, 1 and 96. We're going to end up here at 97 over 64. You could simplify that. You could write it as a mixed number. It's not going to reduce down any further. That's going to just sort of be what it is. 64 is only made of 2's if we broke it down. 2 times 2 times 2, it's 2 all the ways down. I think it's 2 to the 6th. 97 is not even, so there's no numbers here in common. You could write it as a mixed number. This would be 1 and 33 over 64, something like that. That's not really better or worse. It just sort of is different, and it's really sort of up to you how you want to write it. So that's a couple just sort of quick basic order of operations ones. Obviously, there's a lot of different variations you can do here, but I don't want to make 2, 3, 4, 5, 6, 7 videos just running through all of them. That's the basics. So there you go, 4.7.